Hi students. So today we'll see what are the advantages of minimization. Why we are minimizing the logical expression. The first one is the main important reason is the number of logic gates. The number of logic gates will decreases. So before minimizing the logical expression, suppose the expression may require some 10 to 20 logic gates, but after minimizing the logical expression, it may require only 2 to 3 logic gates. So the number of logic gates will decrease. That is the first advantage. And whenever the number of logic gates are decreased, obviously to implementing that, the cost is also reduced. The cost is also decreases. And when the number of logic gates are very less, then you may get the output very fast. That means the propagation delay. Here propagation delay means the time taken by the circuit to get the output after applying the input. That is propagation delay. The propagation delay is also reduced. And since the number of logic gates reduced, the complexity, the circuit complexity is very less after minimizing the logical expression. So one more advantage is circuit complexity will reduce. And since the total number of circuits is very less, each and every circuit will dissipate some heat. So if you are having very less number of logic gates or less number of gates, obviously the power dissipation is also very less, or it is also reduced. So these are the main advantages of minimizing the logical expression. Now after knowing this minimize advantages, let us simplify, let us minimize some of the expressions, simplify the logical expression. The first one is a plus b into a plus c. So let us a dot a, which is a, and a is multiplying with c, a dot c, ac, and this b dot a, which is equal to ab, and b dot c. So here for the first three terms a is common, so a dot 1 plus c plus b plus bc. So using this above theorems, 1 plus anything is equal to 1, so a dot 1, 1 plus anything is equal to 1, which is equal to a plus bc. So the shortcut for implementing this expression is a plus b dot a plus c. Whenever you are having two sum terms like this, here we are having two sum terms, and we are multiplying these sum terms. So in these two sum terms, a is common. A is common for both the sum terms. Whenever you are having an expression like this, you need to multiply the common variable a dot a plus you need to multiply the remaining terms which are not common, that is b dot c. This is the shortcut we will use whenever while solving any logical expression. So whenever you are having two sum terms, in these two sum terms one variable is common, a is common, so a is multiplying with a, you will get a plus remaining the variables which are not common, here b and c are present, you need to multiply those to bc. So after simplifying the expression, you will get a plus bc. So using the above shortcut, let us solve one of the expression a plus b into a plus b bar into a bar plus b into a bar plus b bar. Let us simplify this expression using the above shortcut. So from these two terms, a is common, we need to multiply with a plus b dot b bar, b dot b bar is 0. Next, take these two terms, in these two terms a bar is common, so multiply these two, a bar plus a bar dot a bar, which is a bar, plus multiply these two, b dot b bar. So using the OR theorem, b dot b bar is 0, b dot b bar is 0. So finally we are having a dot a bar, which is 0. So the final answer for this simplifying this expression is 0. And similarly, let us solve one more question, one more logical expression. A plus b bar plus c, sorry here b, a plus b plus c multiplying with a plus b bar plus c into a plus b plus c bar. Let us simplify this logical expression using the above shortcut. So let us consider these two terms, first one and third one. In these two terms, a plus b is common. A plus b is common. So whatever the variable is common, you need to multiply. So a plus b into a plus b, it is common, a plus b, plus which are not common, you need to multiply. So here in this c, in this sum term c bar, so c dot c bar, and the remaining term we are writing as it is. So finally we are getting a plus b, c dot c bar is 0, a plus b bar plus c. So let us consider these two terms. In these two sum terms, a is common. So the answer is a plus. You need to multiply the terms which are not common. In this term b, in this term b bar plus c. So b into b bar plus c. The answer is a plus b dot b bar is 0 and b dot c. So after simplifying the above expression, the final minimized expression is a plus bc. Next one. Till now we have written a plus b into a plus c is a plus bc. Let us write in the opposite way. That means a plus bc. We can write it as a plus b into a plus c, and this is called as distribution theorem. Distribution theorem. That means if you are having variables like this 1 plus 2 into 3, we can write it as 1 plus 2 multiplied with 1 plus 3, because we will use all these theorems while simplifying the logical expression. Sometimes let us simplify using the above theorem. A plus a bar b. A plus a bar b can be written as using the above theorem. That means we are applying distribution theorem like this: a plus a bar into a plus b. It means a plus a bar is 1 into a plus b. So a plus a bar b is equal to a plus b. And similarly, let us solve one more. A bar plus ab is equal to a bar plus a into a bar plus b. So a bar plus a is equal to 1 into this one, a bar plus b. And a plus a bar b bar. Directly we can write using the above theorem a plus b bar. Similarly, let us simplify this one more expression: a bar plus ab bar. So a bar plus a is equal to 1 and a bar plus b bar. Okay. So using distribution theorem, we are simplifying the above expression. Let us simplify some more expressions. Simplify ab bar plus ab plus a bar b bar. So from these two terms, a is common. So a into b plus b bar plus a bar b bar, it is equal to b plus b bar is equal to 1. So a plus a bar b bar. So using distribution theorem, we can write it like this: a plus b bar. And similarly, let us simplify one more expression: xy plus x bar y plus x y bar. So in these two terms, y is common. X plus x bar is equal to 1. So y plus y bar x we can write. And using distribution theorem, we can expand this expression as y plus y bar into y plus x. So the answer is y plus x. Okay. Next, let us simplify one more. ABC bar plus ABC plus A bar BC plus ABC. Simplify this expression. And the question is this one. Simplify ABC bar plus ABC plus A bar BC plus ABC. Okay, let us say take this one. Let us simplify this expression. So from these two terms, AB is common. So AB into C plus C bar. From these two terms, BC is common. BC into A plus A bar, which is equal to AB plus C bar equal to 1 and A plus A bar is equal to 1. The answer is AB plus BC. So here the expression which you are getting, the final expression, this is one product term and this is one product term. You are adding those two product terms, you are summing up those two product terms. That means the answer is in terms of SOP, sum of products, sum of product term. You are having two product terms, you are adding those two product terms, so the expression is called as SOP format. But if you want to express the same answer in terms of POS, product of sums, that means we have to take common b dot A plus C. So A plus C is one sum term and B is one sum term. Now the answer is expressed like this: POS, product of sum terms. Okay. So I hope you understand till now. In the next video, we will discuss consensus theorem. There are two forms of consensus theorem. We'll discuss in the next video. Thank you.